so this is our AP Chemistry Chapter 3 lesson video part 1. And in this video, we're going to cover section 3.1 through 3.3. Now, all of these sections should be reviewed from Honors Chemistry, so I'm going to go kind of fast because, of course, you've already learned this information. So we're going to hit stoichiometry, reactions, molecular and empirical formula, things like that. So stoichiometry is the area of study that examines the quantities of substances consumed and produced in chemical reactions. So remember, atoms are neither created nor destroyed in any chemical reaction or physical process. Below are the parts of a chemical equation. So the arrow is called the yield sign, and on the left of the yield sign we have reactants, on the right of the yield sign we have products. Since atoms are neither created nor destroyed in a chemical reaction, a chemical equation must have an equal number of atoms of each element on each side of the arrow. So that's where we come to balancing equations. Okay, so we did this in honors, and so we're going to look at it again for just a minute. Okay, so remember, you're allowed to put coefficients. You cannot change, add, or alter a subscript when you're balancing. When balancing equations, the coefficients must be in the lowest whole numbers possible. There are some exceptions if the reaction is particularly describing the reaction of 1 mole of a substance. So every now and then you will see a reaction where you might see a decimal or a fraction as a coefficient, but like I said, that's usually because they are specifically talking about 1 mole of one of the reactants, and that just forces some of the other coefficients to have a fraction or a decimal. So to balance equations, only coefficients can be added, subscripts can never be changed or added. I like to balance hydrogen and oxygen last. Remember, that doesn't always work, but sometimes it makes it easier. If a polyatomic ion stays together on both sides of the arrow, then keep it together when balancing. Again, that's not a rule, it's just something that helps make it easier. If you have an odd number of a substance and you want an even number, try doubling the coefficient. So if I have 3 oxygens and I need it to be even, if I put a 2 in front, then that makes 6 oxygens, which is now an even number. So let's look at the first one. So it says the following diagram represents a chemical reaction in which the red spheres are oxygen atoms and the blue spheres are nitrogen atoms. Write the chemical formulas for the reactants and the products. Well, I know the reactants are on this side. Okay, so for my reactants, I can see that it says red is oxygen, blue is nitrogen. So I can see I have some that are just 2 oxygens, so I've got some O2. But I also have some that are 1 blue and 1 red. So I've got some that are NO. So my reactants would be NO and O2. My products, of course, are on the right. And I can see I have 1 blue and 2 reds. So blue is nitrogen, red is oxygen. So my product is NO2, just like that. Okay, and this is not a 1 right here. This is a comma. I guess I could put an and sign. Alright, so that one should have been pretty easy. So then it says, write a balanced equation for this reaction. Well, I had NO and I had O2, and I was yielding or producing NO2. Those were my reactants and products. So now I just need to balance it. So I have 1 N, 1 N, I have 3 O's and only 2 O's. So see, I have this odd number O right here. So remember, the way to make it even is to just put a 2 in front. So see, now it's 2 O's plus 2, which is 4. But before I worry about O, I've messed up N because I put a 2 in front of it. So now I have 2 N's, so I need a 2 here. And now I have 2 plus 2, which is 4 O's, and 4 O's, just like that. Then it says, is the diagram consistent with the law of conservation of mass? Well, I'm going to have to go back to the diagram. So to find out if it's consistent with the law of conservation of mass, I just need to make sure that I have the same amount of blue and red spheres on my reactant side as I do on my product side. So for reactants, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 red spheres. On my products, I have 2, 4, 6, 8, 10, 12, 14, 16 red spheres. So now I just need to check my blue. I have 1, 2, 3, 4, 5, 6, 7, 8 blues. And here I have 1, 2, 3, 4, 5, 6, 7, 8 blues. So yes, it is consistent because I have the same number of oxygen and nitrogen atoms on both sides of my yield sign. In the following diagram, the white spheres represent hydrogen atoms and the blue spheres represent nitrogen atoms. To be consistent with the law of conservation of mass, how many NH3 molecules should be shown in the right box? Okay, so we have nitrogen, diatomic nitrogen, N2, and we have diatomic hydrogen, H2. So it's asking how many NH3 molecules should be shown in the box. So really I just need to make sure I don't use any more than I have, and I don't not use something that I have. All right, and don't forget to be trying some of these on your own. All right, so I can see I have 6 nitrogen atoms. Okay, so I'll just make my nitrogens black. So I have 6 nitrogen atoms. And I'll keep my hydrogens white. All right, I'm trying to make NH3. Okay, so see, I've used up all my nitrogen atoms. So I'm making NH3. So that means for every one of these, I'm going to have 3 hydrogens. So I'll just do like that. Okay, so I took out 1, 2, 3. I'm going to put 3 on this one. So 1, 2, 3. 3 on this one. 1, 2, 3. 3 on this one. 1, 2, 3. 3 on this one. 1, 2, 3. And 3 on this one. 1, 2, 3. So how many NH3s can I make? I can make 6 NH3 molecules. Now a lot of you probably could have done that in your head. I also can. But I'm just trying to show you a way to do it if you can't do it in your mind. All right, really you could just say, oh, I've got 6 hydrogens and 6 nitrogens and 18 hydrogens, so that's going to make 6 of them. All right, ooh, my eraser's not doing great. My daughter cleaned my board, and I feel like that was a mistake. All right, so 6 NH3 molecules. So when we're writing reactions, sometimes we like to tell the states of matter. So G is gas, L is liquid, S is solid, and AQ is aqueous. And remember, aqueous just means dissolved in water, and that identifies the states of matter of the reactants and the products. Symbols listed above the arrow indicate catalysts. When heat is a catalyst, the delta symbol is used, which is our triangle. Okay, so anything written above the arrow. So see here, it's phosphoric acid is the catalyst. Sometimes water is the catalyst. Sometimes, like it says, heat is the catalyst, and you'll see a triangle written above the arrow. So next one, it says balance this equation. So balancing equations is something that you need to be good at. If you're not already, you need to get to where you can do it very quickly. Okay, you don't want to have to waste a lot of time on balancing equations. Let me get caught up in my answers over here for when we get to the real math. All right, so I like to start with Na. So I have 1 Na, 1 Na. Then I would do hydrogen. I have 2 H's. Here I have 3. So I have that odd number thing happening. This is my odd one, so I'm going to start by putting a 2 in front of it. So see, now it's even. But I messed up Na. So now I have 2 Nas, so I need 2 Nas on the other side. So I'll put a 2. All right, next I'm going to go back to hydrogen now. So I have 2 hydrogens right here. I have 2 plus 2, which is 4 hydrogens. So I need a 2 over here. All right, and then last is oxygen. So I have 2 O's, 2 O's, and I'm done. Okay, so like I said, y'all, if you weren't good at balancing in honors, then you need to get better at it. Okay, you don't want to waste a lot of time balancing. All right, so make sure you pause it, you try these, and we'll look at them together. So for part A, I have 1 Fe, but here I have 2, so I'm going to put a 2 here. I have 2 O's, but here I have 3 O's. Whenever you have a 2 and a 3, just make them both 6. That's the easiest thing to do, because I always tell you just double the odd one anyway. If I double a 3, that gives me 6. And so then what times 2 makes 6? A 3. But the thing you got to remember is you have messed up Fe now. So now on this side you have 4. So instead of a 2 over here, I need a 4. So it's just about going back and forth until you get everything balanced. All right, so let's look at part B. So we have 2 C's, so I'm going to put a 2 here. We have 4 H's. I only have 2 here, so I'm going to put a 2. And then last we have O. So on this side I have 2. Here I have 4 plus 2, which is 6. So what times 2 makes 6? A 3. Just like that. All right, so let's look at our bottom one. So we have 1 Al, 1 Al. I have 3 Cl's. Here I only have 1 Cl. So I'm going to put a 3. I have 3 hydrogens, but here I have 2. So see, this one's kind of weird because we made this one odd, but it's still odd. So what do I always say you do with an odd one? Double it. So I'm going to change this to a 6. But before I do anything else, I have now messed up Cl. So let me go back and fix Cl. So now I have 6 Cl. Here I have 3. So I'm going to put a 2. But before I look at hydrogen, I have messed up aluminum. I now have 2 aluminum. So I'll put a 2 here. Now we can go back to hydrogen. So I have 6 hydrogens. Here I only have 2. So what times 2 makes 6? 8, 3. Okay, and so again, y'all, you got to be able to balance. Sometimes they make you write your own reaction for stoichiometry, and then you got to be able to balance it, and if you get the coefficients wrong, then you're going to miss the problem. All right, so let's talk about some types of reactions for section 3.2. In synthesis, sometimes called combination reactions, 2 or more substances react to form one product. So that's how you recognize synthesis. I always like to say it's like marriage. 2 things are separate or more, it could be more than 2. And they come together as one. So like magnesium and oxygen are separate, and here they're bonded together. The important thing to remember is don't forget your 7 diatomics, NOF, Cl, Br, I, and H. They are diatomic when they're alone. When you make the product, you have to remember to make sure your charge is balanced. So Mg is positive 2, O is negative 2, so that's why they don't have any subscripts over here. So the way you make the reaction work is then you go back and balance it. In decomposition reaction, one substance undergoes a reaction to produce 2 or more products. So this is like a divorce. We have one thing together and it splits apart. And so one thing you'll notice is a lot of times if you have a carbonate, it will split apart into the metal oxide and carbon dioxide. That's a common decomposition reaction you'll see, instead of just breaking up into regular elements. But again, things to remember are those 7 diatomics. They are diatomic when they are by themselves. Remember to balance charges if you're predicting the products of a reaction. Ionic compounds, which remember is a metal and a nonmetal, tend to be solids, and acids tend to be aqueous in a reaction. So if it has you write the solid, liquid, gas, or aqueous, if you have an acid, it's listed as aqueous. And if you make an ionic compound, which is a metal and a nonmetal, so like for example, if you make MgO, that is usually a solid. Because sometimes they won't tell you what it is. All right, so it says write the balanced equations for the following reactions. It says the synthesis reaction that occurs when lithium metal and fluorine gas react. Okay, so I have lithium metal, so lithium is Li. It is not a diatomic. Metal is a solid, unless of course it's mercury. And fluorine gas. Fluorine is F. It is a diatomic, and it told me it's a gas. So that's obviously synthesis. I'm going to bond them together. So Li is positive, F is negative. Notice I didn't bring over the 2 because it only has the 2 when it's by itself. This is a metal. I don't need to do anything to balance my charges. This is a metal and a nonmetal, so I can assume it's a solid. So I'm going to get rid of my charges just because they're unnecessary. So the last thing I need to do is balance it. So I have 2 F's, here only 1 F, so I'll put a 2. Now I have 2 Li, so I'll put a 2, just like that. That's all we're doing, okay? So balancing, hopefully, is coming back to you. All right, next, it says the decomposition reaction that occurs when solid barium carbonate is heated. So we have solid barium carbonate. So barium is Ba, it has a positive 2 charge. Carbonate is CO3, it has a negative 2 charge. So I don't need to do anything to balance my charges, but I'm going to erase them just because they're not necessary. And it told me it's a solid. So remember what I told you a second ago. A lot of times a carbonate will break up into the metal oxide, so barium, positive 2, oxygen, negative 2. So we'll get barium oxide, which is still a metal and a nonmetal. So I'm going to put solid, and carbon dioxide, which you should already know carbon dioxide is a gas. All right, so next thing we need to balance. So we have 1 Ba, 1 Ba, 1 C, 1 C, 3 O's, and then 1 and 2, which is 3 O's. Just like that. All Alright, so like I said, you gotta get good at writing reactions, because especially like on a big free response question or something like that, if it starts out with you writing a reaction, you don't want to miss everything after that just because you didn't write it. Oh, and whoops, I'm sorry, I didn't even read the rest of it. It says it's heated, so of course you'll definitely need your triangle. Sorry about that. I do that a lot where I just don't read the whole question. Exactly what a teacher tells you not to do. We always say read all the questions and all the answer choices first. And then I didn't read it. Alright, so hints for predicting products. Like in the previous exercise, carbonate ions tend to produce carbon dioxide when they break down. So if you have something with a carbonate, like I said, you're going to get carbon dioxide. Okay, so whatever's bonded to the carbonate, which a lot of times will be a metal, it doesn't have to be here, it's hydrogen. That will remain bonded to one of the oxygens, and then the other two oxygens will bond to carbon to make a carbon dioxide molecule. Alright, so make sure you're trying these on your own. So it says, write the balanced equation for the following reaction. So we have solid mercury 2 sulfide. So mercury is Hg, the Roman numeral means the charge, 2 positive charge. Sulfide is just sulfur with a negative 2 charge. So I don't need to do anything to balance my charges. So it's just HGS, and it is a solid. So it says it decomposes into its elements when heated. So I read the question this time, all the way through, so I know I need heat as my catalyst. Alright, so I'm just going to split it up into its elements. Well, mercury is just Hg, it's not a diatomic. However, what state of matter is mercury? Well, all the metals are naturally solids except mercury, which is naturally a liquid. Alright, and then sulfur is also not a diatomic, but sulfur is a solid naturally. Alright, so hopefully you got that one right. Part B, it says the surface of aluminum metal, so aluminum is Al, it's a metal, so it's a solid because it's not mercury, undergoes a combination reaction with oxygen in the air. So I'm going to put plus, oxygen is a diatomic, so I'm going to put O2, and it's in its gaseous form because it says in the air. So I'm going to bond them together, so I need to make sure to balance my charges. So aluminum has a positive 3 charge, oxygen has a negative 2 charge. So that means I need a 2 here and a 3 here. I'm going to get rid of my charges. And then this is a metal and a non-metal, so I can assume it's a solid. And so last step is we need to balance. And don't worry, I didn't forget to balance this one, it just didn't need it. So I have 1 aluminum, but here I have 2, so I'm going to put a 2. I have 2 oxygens, and here I have 3. So remember, when you have 2 and 3, make them both 6. So what times 2 makes 6? A 3. What times 3 makes 6? A 2. But now I've messed up aluminum. I now have 4 aluminums on this side and only 2 over here. So I need to change this to a 4. Just like that. Alright, so we did all this in honors chem, so hopefully this is all just coming back to you. Please tell me it's all coming back to you. Alright, remember my triangle this time. Alright, so combustion reactions are rapid reactions that produce a flame. They require air, which what they're reacting with in the air is the O2, as a reactant. When hydrocarbons are combusted completely, the products are CO2 and H2O. So this is the generic reaction for the combustion of a hydrocarbon, carbon and hydrogen. It will always make carbon dioxide and water as long as it's complete combustion. There is something called incomplete combustion when there's not enough oxygen, and that's when you get carbon monoxide. However, any time something burns in the presence of oxygen, it's a combustion reaction. It's just a lot of times we like to focus on the hydrocarbons. But like magnesium plus O2 is still a combustion reaction. So it says, write the balanced equation for the reaction that occurs when methanol, and it gives me the formula, is burned in air. Alright, so I have CH3OH, that's my methanol. When it burns in air, remember it's going to react with the oxygen. So plus O2 is going to yield CO2 and H2O. For combustion reactions, a lot of times the hardest thing is just trying to balance them. The rest of it should be pretty easy. So I have 1C, 1C. Here I have 4 H's, 3 and 1. So what do I put in front of here? A 2. Now I have 3 O's, but here I have 2 and 2, which is 4 O's. So I got the weird oddball one. So this is the one messing everybody up, so I'm just going to put a 2 in front of it. Alright, but now I have a 2 in front of C, so I need a 2 here. Now I also have a 2 in front of my H's. So I have 4 H's times 2, which is 8 H's. So I really need a 4 right here. Okay, so now we got everybody rebalanced, we got our oxygens even, so now we still got to figure out what goes right here. Okay, so I have 4 plus 4, which is 8 oxygens on this side. Now I already have 2 right here, so I need 6 more. So what times 2 makes 6? A 3. Just like that. Okay, so yeah, you got to get good at thinking your way through these quickly. You can also use the fraction way that I showed you, or the decimal way. I don't remember which one your class picked. But you can use the decimal way of doubling also. That works too. Alright, but there we go. Alright, so you try this one. I'll assume you've done that. We'll look at it together. So it says, write the balanced equation for the reaction that occurs when ethanol is burned in air. Okay, so this time we just have ethanol instead of methanol. So we have C2H5OH. Remember, when something burns in air, it's reacting with the oxygen. So it's going to make CO2 and H2O. And so then our last step, of course, is to balance it. So I have 2 C's over here, so I'll put a 2 right here. I have 6 H's, 5, 6. So what times 2 makes 6? A 3. Alright, then last thing we have is O. So here I have 4 plus 3, which is 7 O's. I already have 1, so I need 6 more O's. So I just put a 3. Just like that. Alright, again, balancing is something you gotta be fast at. Okay? You don't want to waste a lot of time on the AP exam. It's time. You can't beg your way to extra time. Alright, so next thing we're going to talk about is formula weight, also known as molar mass. So don't freak out and think, oh gosh, this is something different. It's not. We're just going to start out using AMU, and then we'll switch over to grams per mole. So the formula weight of a substance is the sum of the atomic weights of each atom in its chemical formula. So sorry, this should say of. So for example, H2SO4. We know that there are 2 hydrogens. It has a mass of 1 AMU. Remember, we talked about how the mass is on the periodic table. The unit is AMU, atomic mass unit. However, if we're talking about 1 mole of the substance, that's when we can change it to grams. Okay, so we haven't gotten to that just yet in here. Okay, so 1 AMU plus 32 AMU for sulfur plus 16 AMU for oxygen, but we multiply it by 4. So we get 98 AMU. If the chemical formula is that of the molecule, then the formula weight is also called the molecular weight. Alright, so like I said, this is the same thing we do for molar mass, it's just we haven't learned the grams per mole just yet. We'll get to that. So it says calculate the formula weight of sucrose and calcium nitrate. So like I said, because we haven't done grams per mole yet, we're going to stick with AMUs for right now. Okay, so I just look and I have 12 carbon and it has a mass of 12. So I'm going to do 12 times 12. I have a mass of 1 for hydrogen, but I have 22 of them. So I'm going to do 22 times 1. And then I have a mass of 16 for oxygen, but I have 11 of them. So once I do the math, I get 342. And like I said, for now we're just going to call it AMU. Okay, once we get into the moles, we'll change it over to grams per mole, because obviously you know we'll use grams per mole more often than AMU. Alright, the problem is though that y'all have is if I ask you one like this and you have to write the formula. Some of you struggle with writing formulas. If you struggle with writing formulas, you need to go back to my honors chemistry lesson videos for chapters 7 and 9 to get used to writing formulas. So it says calcium nitrate. So calcium has a positive 2 charge. Nitrate is NO3 and it's negative 1. So that means, of course, I need 2 nitrates to balance my charges. And so then we're ready to just add up. So calcium is 40 AMU. Nitrogen is 14 AMU, but I'm going to multiply by 2. So y'all, the 2 goes to everything in the parentheses. So the 2 does not go to CA. All right, and then oxygen is 16 AMU, but I'm going to multiply it by 6, because see, the 2 and the 3 go to oxygen. So you multiply, don't add. And so once I do that, I get 164 AMU. Just like that. All right? So hopefully, formula, weight, molar mass, whatever you want to call it, is not baffling you. Gosh, like, what's baffling me is how hard it is to clean my board right this second. All right, so you try the next couple, and then we'll look at them together. So it says calculate the formula weight of aluminum hydroxide. So aluminum is Al. It has a positive 3 charge. Hydroxide is OH, and it's negative 1. Now this is where you got to be careful. We all know we need a 3 here, but a lot of you will just do that because hydroxide doesn't already have a subscript. But remember, it's still a polyatomic ion, so it still needs the parentheses. If you don't put the parentheses, you won't apply the 3 to the oxygen also, which it needs to be applied to that. All right, so aluminum is 27 AMU. Oxygen is 16 AMU, but I'm going to multiply it by 3 because remember, if you have a subscript outside the parentheses, it goes to everything in the parentheses. Hydrogen has a mass of 1 AMU, but I have 3 hydrogens. And so once I do the math for that, I get about 78 AMU. Just like that. All right, the bottom one should be super easy because they gave us the formula. So carbon is 12, hydrogen is 1 AMU times 3, oxygen is 16, and hydrogen is 1. So once I add all that up, I got about 32 AMU. All right, so again, molar mass / formula weight. We'll switch over to molar mass soon. Hopefully that is something you remember. We did that a ton in honors chem. We just did grams per mole instead of AMU. All right, so the last thing we're going to talk about in this video is percent composition. So percent composition is the percentage by mass contributed by each element in a substance. So sometimes it's called mass percent, sometimes it's called percent composition, and it's just mass of the element over mass of the compound times 100. So it says calculate the percent of carbon, hydrogen, and oxygen by mass in C12H22O11. Okay, so we know percent composition is mass of element over mass of compound times 100. So let's get the mass of our whole compound first. All right, and again, I'm going to stick with grams per mole for this one just because I know you already know what grams per mole is. So my mass for carbon is 12, but I'm going to multiply it by 12. My mass for hydrogen is 1. I'm going to multiply it by 22. And my mass for oxygen is 16. I'm going to multiply it by 11. So when I do that, I get a total mass of 342 grams per mole. So you can stick with AMU right now if you want to. It doesn't matter. I just know you already know grams per mole. And so most of you would be more likely to use that. So I'm just going to start with carbon first. So remember, it's the mass of the element. So y'all, it's not just 12 for carbon. It's 12 times 12. Like you have to take into account you have 12 carbons. So for the mass of carbon, I'm going to use both of those. So that's 144 grams per mole of carbon. And then I do that over the whole compound. So the whole compound is 342 grams per mole. And then to turn it into percentage, I'll multiply by 100. So my grams per mole cancel. So when I do that, I get about 42.11, and then my unit becomes percent because my grams per mole canceled of carbon, because carbon is what we're talking about. So I got carbon, but I still have to do hydrogen and oxygen. So I just move on to the next one. So I'm going to do hydrogen next. So I do my mass of just hydrogen. So I have 22 hydrogens. They each have a mass of 1. So I have 22 grams per mole of hydrogen. And then I do that over the whole thing, which is 342 grams per mole. And then, of course, to make it a percentage, I multiply by 100. My grams per mole cancel. And once I solve, I get 6.43. And then remember, grams per mole canceled, so my unit is percent. And my substance is hydrogen. Okay? Don't forget, number, unit, substance. We do that a lot when we get to these types of math problems. Alright, and then last one is, of course, oxygen. So I just do the same thing. So my percentage of oxygen, I take just the mass of oxygen. So I have 11 oxygens, and they each have a mass of 16. So that gives me 176 grams per mole of oxygen. I put that over the mass of the whole thing. So see how it's just a pattern, that's all it is. 342 grams per mole. I multiply by 100 to give a percentage. My grams per mole cancel. And so I end up getting about 51.46% oxygen. So one way that you can check your answer is once you're done, if you add them up, you should get approximately 100%. I say approximately because remember, you have to think, we round. And so sometimes your rounding can cause you not to get 100% on the dot, but you should be getting incredibly close. Like if you're getting 87%, that's not really close. All right, so make sure you're trying this one. This will be our last one, and hopefully you'll get it right. So it says, calculate the percentage of nitrogen by mass in calcium nitrate. So this one, I don't have to do the whole thing. It's only asking me about nitrogen. But I do have to write the formula still. So calcium is Ca. Ooh, my marker's dying. It has a positive 2 charge. Nitrate's NO3. It has a negative 1. So that means I need 2 nitrates. So I got my formula. So my next step is to add up the molar mass. So calcium is 40. Nitrogen is 14. But remember, I'm going to multiply it by 2. Oxygen 16, but I'm going to multiply it by 6. So that ends up giving me about 164 grams per mole. Alright, so remember, it's only asking me about nitrogen, so I don't have to do calcium or oxygen. Okay, so I do my percentage of nitrogen, it's just my nitrogen. So remember, even though nitrogen's 14, that's not what I'm going to put at the top, because I have 2 nitrogens, so I'm going to put 28 at the top. So 28 grams per mole of nitrogen over my whole thing, which is 164 grams per mole times 100. And then my grams per mole cancel. And so once I divide, I end up getting about 17.07% nitrogen. Alright, so again, hopefully everything that I just covered in this video is coming back to you. The reactions, the types of reactions, the percent composition, the molar mass, all that kind of stuff. Because again, you already learned all this in Honors Chem, so this should just be a review.